Hello everyone and welcome to my presentation. First, I would like to thank you for giving me the opportunity to share my work with you. In this presentation, I will present a model input data of control system of a mining production unit based on ISA-95 approach. I'm gonna show you 5 steps. Introduction, ISA-95 standard, Purdue Enterprise Reference Architecture Modeling, fixed installation at the OCP Group's mining site, and conclusion and objectives. To stay competitive, manufacturers must improve the way they manage production by modifying and adapting their means of production, reducing their manufacturing times, reacting in the very short time to an unexpected event. On the last point, for the unexpected event, reactive or corrective control will be used. So, the piloting of industrial installation is a solution to this problem. The control system is supported by the manufacturing execution system software. It allows the structure and management of the flow of data exchange between the physical production system and the management system. It bridges the gap in between planning system and controlling systems, and it uses the manufacturing information such as equipment, resources, and orders to support manufacturing processes. Morocco is the leading exporter of phosphate and its derivatives, and it's managed by the OCP groups. The OCP group wants to modernize its management of the mining site production by setting up an MES information system in the Gantour-Benger OCP site. So this system ensures the automatic real-time feedback of field data and uses it to refine the piloting of its fixed installation on mining site and optimize performance. But this system knows some limitations, like the accessibility of data, or some data are entered manually, or a lack of performance indicators for production management. So the objective of our study is the development of the conceptual model of input data classification for the Benger fixed installation control system. So, what are the objectives of the ISA-95 standard? First, ISA-95 deals with the different operation areas that support protection, encompassing inventory, quality, and maintenance. It aims to understand the problem of production control in a simple way. So, the standard seeks to facilitate the strategic choices to be implemented by creating a master plan or preliminary study while specifying the nature and scope of the different systems. So, the main objective of the ISA-95 standard are sharing with industrialists a common terminology for the notion handled by the MES, and providing a set of exchange models between the MES and the ERP. So, the ISA-95 has 6 parts. The first one defines the model and terminology. The second part defines the object, models, and attributes. Part 3 defines models of manufacturing operation and management activity. Part 4 defines object, modeling, and attributes of manufacturing operation management. Part 5 describes the business to manufacturing transaction. And finally, the part 6 defines messaging service model. So the ISA-95 establishes the basic standard of how to manage a production environment based on the 5 levels of PERA. PERA addresses the complexities of industrial enterprise, emphasizing the human involvement within the enterprise system. Its goal is to make the process of implementing the enterprise system more understandable and predictable. Like I said, PERA has 5 levels. Level 0 is associated to the physical process of manufacturing, and it is in charge of carrying out a plan. Level 1 is associated to the intelligent device that ensure and manipulate the physical process. Level 2 represents the control and supervision of the underlying activities. Level 3 involves the management of the operations. And finally, level 4 is associated to the business activity of the entire firm. It establishes the goals and guidelines for the underlying levels down to level 0. Before modeling fixed installation data according to the standard, it is essential to understand the parts relating to the production management of this fixed installation. It consists of 3 phases. The first one is the stoning. This stage is designed to be cleared of stones of different layers of each phosphate apart. The phosphate extracted and transported by the truck is received by 2 hoppers, and the stoning is done by 2 stage screens. So the next phase is screening. The cleared of stones phosphate is transported by a conveyor and discharged into a variable aperture distributing channel for supplying 5 hoppers. The screened phosphate is then sent to downstream stocks to be loaded onto the train. For the last phase is the train loading. A train consists of 60 wagons with an average capacity of 61 tons. So the main objective of modeling data is to manage and control fixed installation, to decompose and make reliable the input data, to allow a perfect automation of the fixed installations, and to approve the intelligent modernization of the control system and a complete integration of the digitalization of production into the OCP group. So this figure presents the global model of the fixed installation control system that integrates the different projects affiliated to it. The various projects are classified according to ISA-95 standards. The system's inputs data may contain all the following: images data, sensors data, and phosphate extraction control system, or a part of it. The system received real-time feedback on the operation of the installation through the dispatcher. The model also illustrates the inputs of the global system that are linked to the output that present, in our case, the key performance indicators or KPIs and performance reports. The monitoring of the performance of fixed installation is done through a dispatcher who is the person responsible for receiving and transmitting pure and reliable messages, tracking vehicles and equipment, and recording other important information. These figures show the detailed inputs that can be classified into measures data and seizure parameters data. These data are classified according to the 4 pillars of the ISA-95 standards, namely production, maintenance, quality, and inventory. The collection of this data can be visualized in the manufacturing control and supervisory control section. The processing of this data and decision making is done in the management part through the calculation of the various KPIs. A few KPIs were proposed for each project, like greasing respect rate or energy consumption. These KPIs were determined according to the needs and requirements expressed by the OCP group by doing multiple brainstorming sessions with the managers and operational staff. Once the KPIs are calculated, they are displayed in a dashboard accessible by all the stakeholders concerned. To synthesize, our work is part of a global project which is based on the feedback and processing of this data. This global project is divided in two parts: mobile installation and fixed installation. We refer to system engineering for the decomposition of the global system into several subsystems. And based on ISA-95, we were able to identify and classify this project and their data according to this need of the management of the fixed installation. Here we can see that there are projects or systems that are in several fields, which makes them linked to each other, and the resolution of the problem will be optimal. This work will allow us in the long term to the resolution of malfunction in a linked and optimal way, giving the right information to the right people at the right time, representation of production system using the meta models provided by the ISA-95 standard, and an optimal management of the overall production of the experimental mine. As a conclusion, this work presents a general context of industrial control systems, an overhaul of ISA-95 approach and para modeling, and an identification and classification of the input data of fixed installations. In the future work, it will be needed to define the different parameters influencing the KPIs and generate calculation formulas. This will help in the decision making. Thank you for your attention. Here you will find my email. I will be glad to answer any questions. Thank you.